We'll proceed flux in calculus. Okay, so we have had long discussion in curl in calculus. We have had long discussion in curl in calculus. Now we have flux in calculus. So flux in calculus is surface integral of vector field, whereas curl in calculus is line integral in vector field. Surface integral, line integral in vector field. So line integral in a way, okay, so if I have this vector field is nothing but algebraic vector. In book and other places, it is defined as an algebraic function which generates different set of vectors dependent upon the independent variable. That is called vector field. So if I have a function and parameter of the function are independent variable, if I am taking independent variable as x, y, and z, then there is a function, I mean programming function, Python function. There is a function, consider the name of the function is capital F, and then in parameter is x, y, z. If I pass different set of x, y, z, it would return different static vectors. If I pass x, y, z as 2, 3, 4, it would return a kind of a vector that has some computation over x, y, z. It may return 5i, 20j, 1.3k. So vector field is something which is a function with independent variable. If you pass independent variable, it would return. Now x, y, z, 2, 3, 4 I pass. Suppose I pass 1.5, 2 and 3. Then it would return 5j, 1, 5i, 2.5j and 10k. So depending upon the input, the parameter to the function, the new vector come out. What's happening inside the function? The algebraic vector, a vector has components. A vector has components. First component, second component, third component. These components are not number, they are algebraic functions. Like if I see two component vector, then it is x plus yi plus x plus sine yj. Rather than saying 2i plus 3j, it is x plus yi plus x plus sine yj. If that is the case, then it is vector field. If you keep changing x and y, it will generate different static vectors. Now, if I have a vector field, so this vector field, if I change xy, if this is xy plane, if I take x-axis and y-axis and y-axis, and if I keep changing x value, then at different x, the vector would be different, not in one direction, the way we think of a vector, always in one direction. Direction would change and its magnitude would change. That is vector field. If I have a vector field, algebraic vector, and if I have a line, then vector multiplied by the line, or this vector field is force field, then force multiplied by the distance, that is the work done. If force is vector field and the distance covered by a mass, that is in a line, that is in a curve, that is also a vector field. This is a vector field, this is a vector field. What is force into displacement? This is force and this is displacement from here to here. If that is the case, then force into displacement. Neither force is constant nor displacement is straight. So in that case, it is both are algebraic, and if you want to multiply algebraic thing, then it comes to integral calculus. Then capital F, that is force field dot d dr vector. So that is the line vector. This is also called line integral. What about surface integral? Surface integral. If I have a vector field and I have a surface, this is the surface. Then vector field, vector multiplied by the surface. That is surface integral. Consider I have a vector that is 2i, vector 2i, and I have an area that is 4. 2 into 2, this is a square, this is a rectangle square. 2 into 2 means 4. 2, then what is the surface integral of this vector? Vector is 2i and area. So area also has a direction and perpendicular surface. So this is the area direction. Okay. So if this is area, then area direction is towards x-axis, whereas there is a vector field 2i. So area is 4. So what is the surface integral? Now surface, since both are in same direction, means area vector is in this direction, if both are in same direction, then 2i into 4i, that is 8, is the surface integral. But this vector that I am calculating surface integral means vector into surface. Vector field surface integral, vector field line integral means vector field into line. That's it. If both are algebraic, then we have to come to algebraic integral calculus. Integral calculus. But if I am calculating surface integral, then vector into surface. That's it. So if both are in same direction, we can just multiply 2i into 4i, that is 8. What about if this vector is not along, is not in the surface has x-axis direction, whereas this vector is this direction. Now what is the surface integral? This vector is now 2i plus 3j. So power of this vector is, I always say, 4 plus 9 square root. 2 square plus 3 square square, that is square root of 13. Earlier it was 2i and power was 2 only. Now it is 2i plus 3j, then power is 30, square root of 30. If that is the case, tell me surface integral of this vector with a surface 4i. Then it is now dot product. So this vector, how much is what is the effective vector along this direction? Anyone would ask, because he has to multiply, right? Surface integral means multiplication. He has to multiply. What is the effective vector along x-axis? So vector equation is 2i plus 3j. So effective vector along x-axis is 2i, only 2i, because 3j will not work here. Okay. So I mean 2i plus 3j, this effective vector along x-axis is 2. Effective vector along y-axis is 3. So along this direction it is 2i or 2. 2 into 4 is 8 again. So net surface integral of 2i or 2i plus 3j with the surface, that is 4i, is same. So it is dot product now. So whatever I have the vector dot the surface vector. So 2i plus 3j dot 4i. Now it is 8 again. Okay. Now this vector becomes vector field. Instead of 2i plus 3j, it is x plus yi plus x plus y sin j. Okay. So this is now vector field. Whereas this area was 4i. Now area is like this. Can you see? Now it's the area vector is everywhere, it is different. It is not a straight. It is not a straight. Now you tell me what is the surface integral. Then it comes to calculus. Earlier it was, if vector was capital F and area was capital A, capital F vector dot area vector, capital F vector dot area vector. That was the surface integral. Now it is capital F vector dot dA vector. Area vector becomes d calculus. Now it is integral calculus. Integration over the full surface. That is surface integral. Surface integral over full surface. Okay. Now it is capital F vector dot d small d capital A vector. Integration. for the full surface. If consider if this is the surface, then it is in YZ plane. This is X axis. If something is like this, then it is in YZ plane and its direction is I. Okay, so dA, if I take a small a, any small a here, then it is dy dz, dy dz, dy dz, x x axis, y axis, z axis, x axis, y axis, z axis. If this is the surface, then a small dA is dy dz I vector, and capital F whatever I am taking. Now, if that is the scenario, we were trying, if I have an electric charge, the charge is value is Q, small q. Okay. I did not see what is the unit of Q. What is the unit of Q if it is a charge? But suppose that there is a electric charge small q, and that q is kept at the origin. If x-axis, y-axis, z-axis. This is the origin. At origin, one electric charge is kept and its value is q. If that is the case, then electric field, it would generate omni in a spherical way, and at any distance r, the electric field that is felt is q by r square, q by r square, and it is propagating all around. It is outward direction. If that is the case and I have a sphere all around this origin, if this is the origin where charge is kept and I have a sphere all around and a sphere radius is a, sphere radius is a, then what is the surface integral? What is the surface integral? Now, now this is the everywhere. If I see a surface and if I see electric field, the electric field is perpendicular to the surface everywhere because it is omni. And if it is a spherical surface, then at surface everywhere it is perpendicular to the surface. So surface, if I have a surface, then surface area vector is perpendicular to the surface. It is kind of radial. In that sense, the electric field and surface vector are in same direction. If that is the case, then what is the surface integral? Whatever we have, that is q by r square into surface area of the sphere, that is 4 pi r square. R square gone, and it is 4 pi q. 4 pi q is the net surface integral. What is surface integral? It is easy to say. Surface integral is nothing but how much is the volume of the electric field that is passing through the surface per second. Okay. So consider surface integral is also called flux. Flux. Consider that there is a container. This is a container and one side it is empty. One side I can push and other side it is closed. One side open and one side it is closed. Now I have a pipe where water is coming, and water is coming exactly like this. So I place the pipe here, okay, and switched on the pipe, means switched on the water. Now water came and it filled it. Immediately it filled it. Okay. And consider that this side, if pipe would close this mouth, pipe, there is a pipe like this, and pipe would close this mouth. Okay. And now when water comes, first it will fill it. Okay. Or consider that, how I can say, okay, consider how many seconds it will take it to fill it. The water comes, and suppose this volume of this container is v meter cube, v meter cube. Okay, it is not in meter, but consider v meter cube, and it takes 5 seconds. Just imagine how velocity of the water is, and it takes 5 seconds to fill this container. Then what is the volume if I consider this surface, because water is entering from this surface, right? So how much is the volume of water that is passing through this surface per second? If it if this full volume is V meter cube and it takes 5 seconds, then V by 5, that much meter cube water is entering from this surface. That is surface integral, where the water velocity is the vector field. If water velocity is the vector field, then velocity I can say meter per second into the surface. What is surface here? This full is the surface and this side is the surface. Full is the surface and this side is the surface. I have to add this surface and this surface. That much is the surface. Oh, I'm sorry. I made a mistake. So the surface is this side. Water is entering. Okay, I believe I'm screwing something. Okay, leave it. Consider this is a surface. No, it is a flat surface. If this is a surface and water is coming here and it is crossing this surface, okay, so consider that surface is hollow, okay, surface is hollow and water is passing the surface. The radius is a, so area is pi a square. Now water is passing here. Now you tell me, now whatever is water is passing through this surface, you are collecting somewhere, and you tell me how much is the volume of the water that you have collected in 10 seconds. Consider it is V. Then V by 10, that much is the volume per second of water that is passing this surface. If water is passing and this water I am collecting somewhere, and at end of 10 seconds, I am seeing what is the volume of the water that is collected. If it is V meter cube, then V by, and it takes T time, T second, then V by 10, V by T, that much meter cube of the water that is passing per second from the surface. That is called flux or surface integral. Okay. Now, if I have a Q charge that is placed at the origin and there is a spherical surface, then at any distance r, the electric field is Q by r square. Then from the spherical surface, what is the flux? What is the net volume of the electric field that is passing per second? That is 4 pi. That is what we calculated was 4 pi 4 pi a square is the surface area into q by r square. So 4 pi q. 4 pi q is the net flux of this to flux. Flux means what is the rate of flow of something through a surface. Rate of flow or volume that is flowing through the surface per second. So if I have a sphere of radius a and there is a q charge placed at the origin, if there is a q charge that is placed at the origin, then net outflow of the flux or net flow per second or net volume of the electric field that is passing through all full surface per second when radius is a is 4 pi q. This is what we saw now. We can go with calculus also. So if I have what is the sphere surface, if I say what is the surface integral, that is capital F vector, that is vector field dot dA vector and integration over full surface. dA vector for a spherical surface is now a sphere. If I have a sphere and a sphere, a small section of the sphere, if I take out, then if I'm taking a surface area, area means it has two sides. One side is vertical arc and other side is horizontal arc. If I take a small volume dV, then third side volume is three sides. One is vertical arc, one is horizontal arc, and third is the radius. That will constitute a volume. But if I have a omnisphere and if I take a surface of the sphere and surface area, surface small area, that is delta A, if I am taking, then delta A is nothing but The arc, the vertical arc, if I have a sphere, then it has two arcs, right? One is horizontal arc and one is vertical arc. Like if I take Earth globe, there are two equatorial. One is equatorial that we see it passes through Africa and it passes through South America, okay, and it passes through Singapore, Indonesia. So these places, the equatorial line it passes through one equatorial. Other equatorial is vertically also one equatorial passes through from the South Pole to North Pole. So there are two things in a sphere. Third thing is the radius. There are three orthogonal components. If I have Earth and if I take if I have surface area of the Earth, if I take any delta area, then it will constitute because radius is constant. So that is the full radius of the sphere. So delta A will constitute the equatorial arc, horizontal equatorial arc and vertical equatorial arc. So at any location, consider this is the if this is the vertical side and this is horizontal side. From vertical, if I take this radius, this is the radius. Consider any radius is omni in a sphere. If I take any radius, then it has angle from vertical as phi. Then vertical arc, if I say delta A, then it is A delta phi. A d phi. Okay, A delta phi is the vertical arc length. Now, what is about horizontal arc length? Horizontal arc length, if I take, then here I have a circle. Okay, this radius of the sphere, it starts from here, which length is A, here length is A, here length is A, but now it is in horizontal equatorial. Here it is in vertical equatorial. Now horizontal equatorial, then it will go up till here. So from 0 to pi, it moves vertically, okay, while in horizontally it moves 0 to 2 pi. If I am taking a delta A, then if they are making phi angle with the vertical, then this arc is A delta phi. And this arc, now there is a circle, I can make a circle, right? So this circle, this radius, full radius is this one. But if it is here, then this radius is A sine phi. Means this will fall here. This is what the length is. So if this is phi, then this will come as vertical. This is horizontal. So it is A sine phi. A sine phi and d theta, because theta will go to pi. So what we are calculating is capital F dot dA vector. So A vector, now A vector, if this is surface, then A vector is along R direction, whereas electric field is also R direction. So capital F dot A vector, so vector I can take it off because dot product has no meaning because they are in same direction. Now capital F is Q by R square. Capital F is Q by R square, where area is multiplication of these two. So one is R d phi, one is R d phi. Okay. Now if I'm taking R as A, the full radius, then it is Q by A square. That is the magnitude of electric field at surface of a sphere of radius A, Q by A square. Okay, Q by A square and multiplied by delta A has two sides. One side is A sine phi d theta and another is A d phi. So A square sine phi d phi d theta. A square, they gone. Or if I take in variable also, but A is not variable now. It is constant because we are taking at the surface. Anyway, A square gone. Now it is Q sine phi d theta. Now phi is from 0 to 2 pi, 0 to pi, and theta is 0 to 2 pi. So I have sine phi d phi. Integration of sine phi is minus cos phi. So minus cos phi 0 to pi. Okay. So cos pi is minus 1, so minus 1, it becomes 2. Okay, so it becomes 2 q into 2 and theta 0 to 2 pi, so it becomes 2 pi 4 pi q here also. So 4 pi q is the net flux that is coming out of the sphere surface if I place charge q. Okay, consider that this charge q is kept at the origin. This charge q is kept at the origin. Charge q is kept at the origin, and I place a cube around the origin with, with length as 2. The cube length is 2, 2, 2, this side 2, this side 2, and it is centered at the origin where charge q is kept. Electric field of this charge q is is q by r square, where r is the spherical radial distance. If that is the case, and if I take direction now, then it becomes q by r to the power q by r to the power 3 r vector, because r vector I have introduced now. So q by r to the power 3 r vector. Surface integral along the cube. So if I calculate surface integral, no, for a charge, all surface are at equal distance and same angle. This proves that one side, if I calculate the flux, I can multiply by 6. Okay, if that is the case, consider I am taking the, if this is the origin, this is x-axis, this is y-axis, this is z-axis. Along the y-axis, that phase I am taking. Or if it is not clear, then if it is x-axis, then along the x-axis, that phase I am taking. So this is 1 unit distance. Height is 1 unit. And full width is 2 units. From here 1 unit, from here 1. This phase if I am taking, then it is facing toward y-axis. Facing toward y-axis. And if I take any delta area, that is dy dz. Dy dz. Okay. Now, what is Cartesian coordinate? What is the equation for this vector? That is q r vector divided by r to the power 3. So it is q r vector is xi plus yj plus zk divided by r to the power 3, that is x square plus y square plus z square 3 by 2. So that is the kind of Cartesian coordinate equation. Dot dA vector, that is dy dz I vector. Now if I do dot, then j and k component go on, only I vector remains xi divided by square root of x square plus y square plus z square dx dy. Sorry, dy dz. So xy square root of x square plus y square plus z square. If I integrate with dy, I can take x as constant and z as constant. So x square I can keep outside. 1 by x square plus y square plus z square to the power 3 by 2, or 1 by y square plus x square plus z square to the power 3 by 2, where x square plus z square is constant. Still, I don't know what is the equation for this. Okay, someone can try, or I can find out. So the net is x by square root a to x by x square plus y square plus z square. Sorry, y square plus x square plus z square to the power 3 by 2 dy dz. First integrate with the dy, then so numerical integral we can take. Numerical integral means we can chop into many sections. Okay, and then we do the addition. We'll take one class on numerical integration, and we chop in the multiple section, and then we, like if I take numerical integration, it is 3D. If I take in 2D, or here this also I can make in 2D, where if it is x-axis and if I have to calculate integration of a function for which I don't know the integration, then I can subdivide into many parts. Okay, and for each part I can take center location as the height, whatever the height is. Calculate the inference is calculate the separate area. If I said x by square root of y square plus x square plus z square, then this is, consider this is y axis. If this is y-axis, then I have to do in dy. Integration of dy is from -1 to +1. So -1 to +1, in between I can take 10 ranges. -1 to -0.8, -0.8 to -0.6. Like this, I can chop into 10 sections. Now for each section, now x x is anyway 1. X is fixed, right? If it is a cube and I have taken the face here on x-axis, the x is anyway 1. So it is 1 by a square root of y square plus 1 plus z square. Okay, that is the case. Now we can keeping 1 and z square as constant, and y, if I keep changing, y when it is 0, y when it is 0.5, y when whatever at each location. Now you calculate the height value, that will whatever it comes, and then this is integral, this is numerical integral. Means you have to find kind of Riemann summation. Riemann summation, this is a called. Then you will find it. Or if you know what is the integration of x by square root of y square plus x square plus z square dy, then you can get the answer. But net integration y is from -1 to 1, -1 to 1, and z is -1 to 1. Whatever comes, multiply it by 6. Probably it will come similar to 4 pi q, what we saw. Okay, now this whatever we have done, it is a kind of kacha vacha, means we were not serious about the area vector. How to calculate area vector and proceed. Okay, so if I have, consider this is the container, and water is coming here, and it is how I can say. Okay, this is kind of a 3D model, and consider the charge, electric charge is kept at the center, and this is centered at the origin. How much is the charge coming out of the surface? That is the question. Now everywhere dA vector is different. Can you see? It's not a flat. If it is flat, then everywhere dA vector is perpendicular to the surface. But here it is perpendicular to the surface, but everywhere perpendicular is different. dA vector is different. How I can calculate dA vector? That is the big question. If I have a vector field in Cartesian coordinate, vector field like we had right now, right? Q xi plus yj plus zk divided by x square plus y square plus z square into 3 by 2. If this is the vector field, then what is the surface area? How I can calculate the vector? How I can calculate the vector equation in a vector, algebraic vector of a area? What is area vector? If I have a sphere, then what is the area vector? If I have any shape, then what is the area vector? If area vector is varying every moment, if this is the full surface area, then area vector is varying like this. Can you see every moment? Here it is constant. Here it is constant. This side it is constant. It is flat. But altogether area vector is too many. So it is candidate for the algebraic area vector. That is vector field. Now dA, area vector is vector field, capital F is vector field. But how to calculate area vector? That is a big question. Okay, we will see. So this is our way that we will calculate area vector, and it is not mentioned in any of the book. Okay, how you calculate area vector? So can if I have a position vector of, if I have a surface, if it is a 3D, and if I have a surface, then every moment the area vector is different if surface is not flat. If that is the case, then the every moment area vector is function of xyz, because if I keep changing xy, function of xy, if it is independent variable is xy only. If that is the case, then if this is xy plane and this is a surface, if I keep changing xy in the xy plane, accordingly the surface point would be different. and accordingly the area vector will be different. So area vector is nothing but it is dependent upon x and y, that is the vector field. But how I can calculate area vector? Any point on the surface I can address it as xi plus yj plus zk as position vector. If this is the sphere, it is centered at the origin. Consider this point is inside the origin, and wherever I take any point at the sphere at x, y, z, then position vector would be xi plus yj plus zk. Okay, but that is the position that is the position vector. But what about area vector? This is point. If I take any point, its vector is xi plus yj plus zk. What about surface area vector? What it is? Surface area vector. If I come to know surface area vector, then through calculus I can do integration capital F dot dA vector, where capital F is algebraic vector dot dA. A is algebraic vector. So how we can calculate the area vector? That is a big question. So that we will see.